Okay, it's time for some more fun with implicit differentiation. I know it's your favorite thing ever. Okay, jumping right in. So we have tangent y, so derivative of the outside. Because remember, chain rule. Derivative of the outside, so secant squared. There's derivative of the outside, while keeping the inside the same, times derivative of the inside. Okay, next piece here, this 2x cubed y squared. I'm going to just come over here and say what my y and y prime are, or u and u prime are. Actually, I'm going to scoot over a little just to make sure I have room. So u is going to be 2x cubed, so u prime 6x squared. And then v is y squared. V prime is derivative of the outside, so 2. Keep the inside the same. That's the y, because remember I could put that y in parentheses. And then derivative of the inside, so the derivative of y squared, 2y dy dx. So back to here, using our product rule. So plus u prime, 6x squared, times v, y squared, plus u, which is 2x cubed, times v prime 2y dy dx. So this whole pile of stuff is our derivative of 2x cubed y squared, and then equals 2. So then once again, we need to get the dy dx stuff, because we're solving for dy dx next. We need dy dx stuff on one side, not dy dx stuff on the other. So I'll subtract the 6x squared y squared from both sides. So I have secant squared y times dy dx plus, I'll clean that up, 4x cubed y dy dx equals 2 minus 6x squared y squared. And I should have done this before I started solving for dy dx, but just doing some quality assurance here. I have 2 y's in the original equation. Do I have 2 dy dx's in my derivative? 1, 2. Yes, I do. Always check that. It doesn't guarantee you've done things right, but at least it increases the odds. Once we have it so the dy dx stuff is on one side and the not dy dx stuff is on the other, we can factor dy dx out. So we have dy dx times all this other stuff, secant squared y plus 4x cubed y. And that equals the 2 minus 6x squared y squared. To get dy dx alone, I just divide by the stuff that's multiplying there. So dy dx equals 2 minus 6x squared y squared over the secant squared y plus 4x cubed y. Just a reminder that we have that Desmos app. If you're just curious about what these functions look like, it's, I don't know, cheap entertainment because the app is free. One thing you can't do, unfortunately, like we don't have a way we could put this in, and that's a bummer. But we just don't have that power. Okay, let's do another one. It's going to be spicy too, so I'm going to put a 3 in front of that. Okay, so looking at this 3xy, for some reason people end up doing some weird things here when they're looking at their product rule. Like they'll have the 3 on the outside and then they have u and v as just x and y respectively. I think it's easier to say that u is 3x, so u prime is 3. And then v is going to be y, so v prime is dy dx. Because yeah, we have to product rule that. And we have that here. So we have u prime, which is 3, times v, which is y, plus u, which is 3x, and v prime, which is dy dx. And remember, it's really, really a good idea to write this down. Even if it's like, I'm not saying any of these are simple, but like this one is a relatively simple product. It's a lot simpler actually than the last product we had. So just kind of be careful there. I'm going to really mess with your heads. I'm going to just add something here. I can just keep making this problem worse, don't I? Okay, so here's the derivative of the left side. Going to the right side, we have the derivative of sine x squared. So derivative of the outside is cosine. keep the inside the same, x squared, times derivative of the inside, we have a 2x. Plus derivative of cosine, we get negative sine, keep the inside the same, y cubed. Derivative of the inside, be careful here, we have 3y squared times dy dx. So we have a double chain rule, remember, because like we have that, like you can think of that y as in parentheses, and you can think of the whole thing in parentheses again. And it looks like I got in my own way. It happens. Sometimes planning ahead is hard, isn't it? Life is that way. Okay, so we have, so these two pieces are the derivative of sine x squared and cosine y cubed. And now, oh gosh, what the heck? That's so gross, isn't it? Let's just get some u and u prime stuff happening here. I'm going to write it above. So I'm going to do negative 3y to the point 2 as my u. So u prime is going to be negative 0.6, because negative 3 times 0.2, y to the subtracting 1, so I get negative 0.8. And remember that you could put parentheses around that y, so the derivative of the inside being dy dx. And then v is x to the 0.4, v prime is 0.4x to the negative 0.6. What was I thinking when I wrote this problem? I know, I wanted to give a spicy one. One of those, if you can do this problem, you're really good at this. Sometimes the algebra becomes harder than the calculus on these things. You'll find that a lot in this class, actually. Okay, so now just ignoring all this other stuff just to do our derivative. So u prime, we have that guy. So minus 0.6y to the negative 0.8 dy dx is my u prime times v, x to the 0.4, plus my u, which is negative 3y to the negative 0.2, times v prime, which is 0.4x to the negative 0.6. This thing barely fits on the page. What was I thinking? Okay, double checking some things. 1, 2, 3 times that y was written in the original equation. 1, 2, 3 dy dx's in the derivative. Now we want to get it so we have all the dy dx stuff on one side and the not dy dx stuff on the other side. So I have 2 dy dx, or not dy dx stuff. I'm going to put those 3 all on the left. So I have 3y, and then minus this one, so minus 2x cosine x squared. And then I have, that's a negative, so it'll be a plus 3 times 0.4, 1.2, y to the negative 0.2, x to the negative 0.6. Okay, so there's the left side. On the right, I have all the dy dx stuff. So I have all of this guy here, these pieces here. So I need an equals. I have this right here to start with. So negative, I'm going to rearrange my order just to make it kind of more standard. So negative 3y squared sine y cubed times dy dx. And then I have this guy here, which I'm also going to rearrange to negative 0.6x to the 0.4 y to the negative 0.8 dy dx. And then finally that last piece from the other side, minus 3x dy dx. Whew, this one is terrible, isn't it? I know you're having the most fun you've ever had. Okay, our last piece, looking at this right side, we have these dy dx's. I'm even going to highlight them just to make them really show up. So I have these 3 dy dx's, and I'm going to factor that out to the front on the right side. So my left side is still the same. 3y minus 2x cosine x squared plus 1.2y to the negative 0.2 x to the negative 0.6. If I were really standardized things, I would have written it the x before the y, but whatever. Equals, factor the dy dx out, leaving me all the rest of the stuff. Negative 3y squared sine y cubed. And then minus 0.6x to the 0.4y to the negative 0.8 minus 3x. And then finally, the last piece is I can divide both sides by the contents of these parentheses here, leaving me dy dx equals, I know I could have done blah, blah, blah equals, but all of this stuff on the top, 3y minus 2x cosine x squared plus 1.2y to the negative 0.2 x to the negative 0.6, all of that over the stuff in parentheses. Negative 3y squared sine y cubed minus 0.6 x to the 0.4 y to the negative 0.8 minus 3x. Bam. And we're done. So this is just pretty gnarly on just how many details and steps there are in it. If you can pull this kind of problem off, you're really good at implicit differentiation. There's no getting around it. The stuff is tricky and it really takes the practice, and you just have to keep trying. And it will come together as long as you keep trying.